Edx M3 January 2010 question 4 on elastic strings and Hooke's law and the elastic potential energy. 10 marks for what looks like a fairly short question. Take your time to read it, pause the video. Here's the same diagram but with the forces added. So we've got a weight 40 newtons, light elastic string, natural length 0.5, and two forces holding it in equilibrium like that. What we're going to need for this question, let's just jot down these facts. T is lambda x over L, Hooke's law, and elastic potential energy is lambda x squared over 2L. Alright, let's resolve now then, because it's crying out for resolving either that or a triangle of forces to represent the equilibrium. I'll resolve. We've got resolving vertically, t cos theta equals 40, and resolving horizontally, t sin theta equals 30. Now those equations are quite nice because we can divide to give tan theta is 3/4, and that will tell us sin theta and cos theta. If you think about it, we've got 3, 4, 5 theta there. So sin theta is 3/5 and cos theta is 4/5. Not only that, we can find the tension now. We could square and add because cos squared plus sin squared is 1. Or since cos theta and sin theta are so simple, let's just put sin theta into the second one. T times 3/5 equals 30, so T equals 50 newtons. Right, we found the tension in the string. Now how does that help? Well, tension is related to extension. We also know, if you read the question, read it again if you haven't noticed, but we also know the elastic potential energy is 10. That's what they tell us in the question. So this is going to give us two equations. There are two unknowns because they haven't told us lambda. L is 0.5. On the next page then, let's use these. So T is 50, gives us the equation 50 equals lambda x over 0.5, L is 0.5. And the elastic potential energy 10 equals lambda x squared over 2L, 1.0. So lambda x equals, what does that give us? Lambda x equals 25 and lambda x squared equals 10. Again, a nice pair of equations. We can divide them as well. Dividing the second by the first, we get x equals 10 over 25. So x equals 0.4. Now the question actually asked for the length of the string, so all you've got to do now is add the unstretched length onto that. The length is 0.5 plus 0.4, which is 0.9. And that's it. The marks for that question, let's go back to the previous page and just put them in there. For resolving, method mark for attempting to resolve and 2 accuracy marks for that. For finding T, an M1A1. That's half the marks for the question then. And then carrying on the next page, there was a mark for that statement there, and a mark for, I'm not sure why they gave one mark as a B and one as an M, but a B1 and an M1 for those two. And then for attempting to solve them, there was a method mark. For getting x equals 0.4, there was an accuracy mark, and then for getting the final answer, one more accuracy mark. And that gives a total of 10 marks. Thank you for listening. I hope that was useful.